Okay, in this video we're going to take a look at Max Sum Subarray coding challenge. So the interviewer could ask us to create a function that accepts one argument, and that's an array. And we have an example here. So we have an array of integers, and they can be either positive or negative. And what we need to return is the maximum sum subarray. For this example, the return value would be 7. That's because 3 plus 4 is 7, and this is our maximum subarray. So the numbers needs to be contiguous, so it needs to be together. Yeah, and that's the problem. So I'll give you a minute to think about how you would solve this problem, and then we can do it ourselves. So one way of solving this would be using brute force approach. So we would start from first element, first number, and go left and right. And we would do this for each number and just save our maximum sum subarray, right? But this would give us an O of n square runtime, which is slow, right? We could do better, and we actually could use dynamic programming for this problem. What we do is we create DP array, and we will be solving problem on each step of the way. So and another thing we need to do is have another variable that would hold up the maximum current sum subarray, right? So for the first element we just write 1 because this is max, and then when we go to index 1, we can either choose so the number upwards, or we can choose this number plus what we have in DP array. So in this example, the bigger number is so we can choose either -2 or -2 plus 1, which is -1. So we choose -1 here. Okay, we move forward, and in this example we can either choose 3 or 2, right? Because this sums to 2. And we choose 3, and we of course update our results to being 3. Cool, let's move forward. In this example we can choose either 4 or 4 plus 3, which is 7. We choose 7, and we need to update our results variable. We move forward and we can choose -5 or -5 plus 7, which is 2. So we choose 2, and at the end we just return what we have in our results variable. Cool. So if we talk about runtime here, so the time is O of n is the number of elements inside an array, and for space it's also O of n because we're constructing additional an array for this solution. But we will see in our example that we can actually reduce our space to being constant, because we're not actually using all of the numbers here, we're just using our previous value, right? Cool. So let's look at the code. So we'll have an array, this, and if we print max sum subarray like this, we should get a value of 7 here. Let's create our DP. We can prefill it with none, like this. Our first value can be first value from an array. The same for results. Do DP 0 like this, and then we just have for loop for I in range. We start with 1, length DP like this. can have current, which just points to whatever is maximum of a of I, either this number or a of I plus dp I minus 1, like this, right? Of course, we update the results variable to being max result or current. And after we're done, oh, we need to update dp as well, right? Like this, it's current. And after we're done, we just return the results, like this. And we get 7, right? We can also print dp to just see what has happened here. So like we did in our example, we have our intermediate values inside dp array. So runtime would be O of n, like we discussed, and O of n is space as well. Now we can reduce this space to not create our dp array. So we would do this by just having our current value, which can be 0, and the results the current, and then for I in range, do the same like this. So our current value would be max between a of I and a of I plus current. And we also update the results with results and current. After we're done, we just return results like this. And if we run the code, we should get 7 back. And we do. That's awesome. Cool. So that's it for this problem, and see you guys next time. Bye.